Good afternoon, students. This is SP Smart School Learning Program. The subject is chemistry. In this video, we are going to discuss soap. Carbon and its compound form an integral part of our lives. From the food to medicine, from textile to laboratory, these organic compounds find place everywhere. The carbon compound having phenomenal applications as well as right from killing, trapping microorganisms to cleaning our clothes. They perform numerous amazing tasks. So we will discuss how the carbon are used for cleaning our clothes. How is that in the form of soap, the soap carbon compounds are used? Yes, they are. They are chemically the salt of fatty acids. Let us understand this fatty acids are extremely long chain of hydrocarbons with carboxylic acid attached at the one terminal. Since soap are the salt of fatty acids, they have sodium and potassium attached to the chain. So the structure of the soap can be seen as a long chain of hydrocarbons, which can be saturated or unsaturated. And the chain will have a carboxylic terminal and the sodium and potassium attached to it. So, the typical structure of the soap appears to be like this. So, chemically, soaps are represented as RCOONA, RCOOK, whether it has sodium or potassium attached to it, and R represent a long hydrocarbon chain. So, it is understood that these kinds of huge structure cannot be written precisely every time. That is why we represent the soap molecule using this structure. The ball on the top represents the carboxylic terminal with the sodium or the potassium attached. This end is called as the hydrophilic end or the head region. As we know, hydra means water and philic means loving. So this end is attracted towards the water or being around with the water. And the other part, that is the tail, which is made up of hydrocarbons, is the hydrophobic end, which means the group that fear being with the water. So it is the position that tries to be away from the water. Hence, this hydrophilic part gets attached to the water towards the polar molecule like water is called as the polar end, and the other region is called as the non-polar end, and it get attached towards the non-polar molecule like grease or oil. Now we will discuss how soap in water works. As the soap molecule contains a polar head and a non-polar tail. So head is hydrophilic and the tail is hydrophobic. A number of soap molecules combine as the head is attracted towards water and the tail traps the grease or the oil. A spherical aggregate is formed and is called as the mishel. So, when it finds the grease or the dirt on the surface, it surrounds and latches onto the dirt. And as we apply friction by scrubbing, it pulls it from the surface, causing it to float around the soap solution, and then we rinse the surface off